So questions from topic 6, the chemical reaction. A student prepare calcium nitrate by adding calcium carbonate to nitric acid. Write a chemical equation for this. So when metal calcium carbonate is there, and it is reacting with nitric acid. So first, what will the formula for calcium carbonate? The calcium is group 2 plus 2 and carbonate is minus 2. So they have the same valency. So the formula will be CaCO3. Reacted with nitric acid formula is HNO3, hydrogen nitrate, and it will give calcium nitrate. The formula is already given. What else will be the product? Because it's a metal carbonate react with acid. So it will be a salt. Already we know carbon dioxide, and one more product will be there, that is water, H2O. After writing the equation, as I mentioned, always write the equation first and then balancing is the second part. So when you're balancing, you start with oxygen, followed by hydrogen, and then any other element of your choice. So when we start with oxygen, we have 3 and 3 before, like putting this 2. 6 are there. Here 3 multiplied by 2, 6, 7, 8, and 9. So what we can do, if we put 2 here, if we put 2, then this will be balanced. The next one described two observations. What we will observe when this reaction will happen, whenever acid is reacting with carbonate, because of a carbon dioxide, bubbles will be there. And because calcium carbonate is solid, so the solid will dissolve or solid disappear. What if there was a transition element or a transition metal? In that case, we'll mention it will form a colored solution. If it's a non-transition element, then no, it will be a colorless, but if it's a transition metal, it will form a colored solution. Student continue to add calcium carbonate until it is in excess. The student then remove an excess of calcium carbonate by filtration and collect an aqueous calcium nitrate. State the journal term given to a solution collect from filtration. So we call that as a filtrate because, and what is left on the filter paper, that is known as the residue. Then student gently heat an aqueous calcium nitrate until the solution saturates. Suggest what is meant by the term saturated solution. No more solute can dissolve, that is 1 mark. At a specific temperature, at a particular temperature, that is a 2nd mark. So it cannot dissolve, no more solute at a specific temperature. Describe how the crystals are produced from a hot saturated solution. How crystals are produced? Because when the solution cool down, the solubility, what happened to the solubility? The solubility will decrease. When the solution cool down, the solubility of the solution decrease. That's why the crystals will form. So how the crystals are produced from a hot saturated solution? So decrease in temperature, decrease the solubility of the solution. And when the solubility of a solution decreases, the crystals will start to appear or crystals will form. This question is related to the reversible reaction. We have a nitrogen dinitrogen tetroxide, and we have a nitrogen dioxide is there, which is brown in color. The gas range containing a mixture was sealed and heated. After reaching equilibrium, the mixture was pale. What is meant by equilibrium? The term equilibrium means like the rate of forward equals to rate of backward, and there should be no change in concentration of the reactant product. But don't say the reactant product have the same concentration. So we can say rate of forward equals to rate of backward, and there is no change in the concentration. Or forward reaction equals to the backward reaction. The plunger of a gas syringe is pushed in and the temperature does not change. The mixture initially turned dark brown. After a few seconds, the mixture turned light. Look, first initially, First, initially, why the mixture will turn not faster rate, what will happen? The concentration increase. Because look, it's not about initially the concentration increases when we close, when we reduce the size, like example, when we reduce a small in a small space, we'll have a large volume. Sorry, in a small space, we have large number of the particles. So in a small space, as we have a large number of the particles, so the concentration of the particle increases in the space. So as a result of high concentration, color will get darker. That is why, like example, in winter, you can see the smoke easily as compared to that in summer. Because in winter, when the temperature is low, the particles are closer to each other. So say first initially, why the mixture initially turned dark brown? Because the concentration of the particles in a unit volume increases. Then why the position of equilibrium shift towards the left? So here we have 1 mole and 2 moles. So increase in pressure shift the equilibrium towards the side of less moles. So high pressure shift the equilibrium to the side of the less moles. That's why, yeah, the high pressure favor the side of the less moles. You can mention that. The forward reaction is endothermic. What happened to the position of equilibrium when the temperature increased? So if an endothermic reaction favors the increase in temperature, so it will shift towards the right hand side. State what happened to rate of forward and the backward when the temperature of a mixture increased. Rate of forward and backward reaction both are directly proportional to temperature. So even the forward will increase and the backward will also increase. This one, state what happened to the position of equilibrium when the temperature is increased. You have to recall the idea for the reversible reactions. For a reversible reaction can be endothermic. Reversible reactions can be exothermic. If it's an endothermic reaction and you increase the temperature, where the equilibrium will shift, it will shift towards the right hand side. And if you decrease the temperature, the equilibrium will shift towards the left hand side. And same way for exothermic reaction, when you increase the temperature, equilibrium will shift towards the left, and you decrease the temperature, equilibrium will shift towards the right. So what happened in the previous question? As the reversible reaction is endothermic, so for endothermic, what we are doing, we are increasing the temperature. So when we increase the temperature for endothermic reaction, where the equilibrium will shift, it will shift toward the right whenever there's an increase in temperature. Why increase in temperature? Increase the forward and backward reaction both, because both, it's not like you can in a container. When you have a container, you have both reactant and product. Let's say example, these black dots are representing the reactant particle and the red dots are representing the product particles. So when we increase the temperature of the container, as a result, what will happen? The vibration of both reactant and the vibration of the product both increases. That's why the rate will increase. And even if you use a catalyst also alter the rate of both forward and backward. Whenever a catalyst is used, the rate of forward will also increase and the rate of backward will also increase. So in the first stage of a process, it reacts with oxygen, it produces sulfur dioxide. So sulfur dioxide is produced. Iron 3 oxide. So what is the formula of iron 3 oxide? Iron is +3 and oxygen is -2. So iron 3 oxide will be Fe2O3. And copper 2 oxide. So copper 2 oxide, copper is +2 and oxygen is -2. So copper 2 oxide will be CO. Then we have to balance. So we need 4 iron here, 4 Fe. So we have to balance Fe first. So we put 2 Fe's balance. Then copper is 4. So we put 4 copper is balance, and sulfur. 4 multiplied by 2 makes 8 sulfur. So we put 8. So all of them are balanced. Copper sulfide can be formed, but the thing is, in the question they mentioned these are the only product which are formed. That's why multiple products can form depending on the reaction temperature at which the reaction is carried out. But in this example, only copper is oxide is produced rather than copper sulfide. So sulfur dioxide is then converted into sulfur trioxide, and the forward reaction is exothermic. State 2 features of equilibrium: no change in concentration, and the rate of forward equals to rate of backward. So you will mention the first thing, there will be no change in the concentration. And the second thing, rate of forward equals to rate of backward. State the temperature and the pressure used. This is a contact process. So what is the temperature? 450. And what is the pressure? 2 to 3 atm or 2 to 5 atm is also acceptable. 2 atm is fine. Name the catalyst used. So we use vanadium pentoxide. Vanadium 5 oxide, good. Why is the catalyst used for this reaction? So what is the purpose of the catalyst? Catalyst is used to increase the rate of reaction, and it does not change chemically to speed up a reaction or alter the rate of reaction. It is fine if you mention 1 to 2 atm, that is fine. 2 to 5 atm is also correct for the Haber's process. Then describe in terms of equilibrium what happened when the temperature increased. This forward reaction was exothermic. S2SO2 plus O2 gives 2SO3. And they mentioned the forward reaction is exothermic. So if the forward reaction is exothermic, so when we increase the temperature, the equilibrium will shift towards the left-hand side, which reduce the yield. So you will mention the forward reaction is exothermic. So increase in temperature, shift the equilibrium towards the left-hand side. Concentrated sulfuric acid is a dehydrating agent. Dehydrating agent means it removes water. When a glucose is dehydrated, the carbon and one other product is there. So because it's a dehydrating agent, so what it will produce? Water. Then we have to balance this equation. Whenever you're balancing equation, start with oxygen, followed by hydrogen, and then any other element. But for a combustion equation, start with carbon, followed by hydrogen, and then at the last oxygen. So this is a balance equation for a glucose. Dehydration of a glucose by sulfuric acid. So this is topic